Welcome to Brain Vision.
Okay, you have to find the area of the part of the sphere that's inside the cylinder, and I'm guessing you mean the volume. Let's assume that's what you meant and go from there. Okay, we have this sphere and its radius is A. Okay, so it'll be that big. Oops. Oops. Okay. There you go. That's kind of the sphere. And then we have a cylinder, and it doesn't have a Z in it, so I know that it's going up and down. But let's do this. Let's complete the square so we can see where it is. So half of A squared. So A squared over 4. X minus A over 2 squared plus Y squared equals A over 2 squared. So it's out here at A over 2, and its radius is A over 2. So it's like right here. Okay. So if we're going to find the volume, it's going to be Z on the top minus Z on the bottom, which is just the sphere. And then we'll integrate over this circle in the XY plane. Okay, so here's what I just said. Z on the top. I don't know if you're doing double or triple integrals. It doesn't matter because it'll end up being this A squared minus X squared minus Y squared minus that. So two of those, top minus bottom, dz. And then here, this is X, Y. This is A over 2. Top of the circle minus the bottom of the circle, or top of bottom to top. So minus A squared minus X squared, A squared minus X squared, and then 0 to A. Okay, gross. Oh, sorry, no dz in there because we're only doing double integrals. Okay, so I took care of that by putting 2 there. Okay, so that's a mess. So let's go ahead and switch to polar. And we know x squared plus y squared equals r squared. And dy dz is r dr d theta. And r is going from 0 out to this circle. So we need to fix it. It, remember, was x squared plus y squared equals ax. So r squared equals ar cosine theta, or r equals a cosine theta. Oh yeah, this isn't so bad. 0 to a cosine theta, 2 square root of a squared minus r squared, r dr d theta. And then to get all the way around the circle, you only have to go 0 to pi. Okay, because the cosine looks like this. And so this will be the beginning of the circle. This will be when that's the beginning. and then that's when it gets to 0 right there at pi over 2, and then it gets back to the beginning again before, right when it gets to pi. Okay. Okay, I'm satisfied now. Okay, so we're going to let u be a squared minus r squared. So du is minus 2r dr. So we need a minus 2 there and a minus 1/2 out there. So minus 1/2 2 u to the 1/2 du d theta. Oh, I had a 2. Okay, that's why that's so weird. Okay, so minus 1 u to the 3/2 over 3/2 or to the 2/3 d theta. So minus 2/3 a squared minus r squared to the 3/2 from 0 to a cosine theta d theta. That's, I was having trouble because I usually switch the endpoints and I forgot. Minus 2/3 integral a squared minus a squared cosine squared to the 3/2 minus, oh, don't forget to plug the 0 in, a squared minus 0 squared to the 3/2 d theta minus 2/3 integral. Okay, if I factor down an a squared, I'll have a 1 minus cosine squared, which is the sine squared. So when I raise it to the 3rd power, I get a cubed sine cubed theta minus, here I got a cubed d theta. So minus 2/3 a cubed. Oh, this problem is kind of sucky. All right, I'm going to make the sine cubed into sine squared, sine d theta minus 1 d theta, because I put the a cubed out here. I'm a little worried about that minus sign. Okay, that's 1 minus cosine squared, sine theta d theta minus theta. All right, first integral is just the sine, so that's minus the cosine, minus, if u is the cosine, then du needs to be minus, so plus cosine cubed over 3 minus theta from 0 to pi minus 2/3 a cubed minus 1 plus minus 1 cubed over 3 minus pi minus the cosine of 0, so minus 1 plus 1 cubed, 1 over 3 minus 0 minus 2/3 a cubed 1 minus 1/3 minus pi minus 2/3. So that's 2/3 plus 2/3, 4/3. That can't be right. Oh, yeah. 4/3 minus pi, that's negative, and we're multiplying by a negative 2/3. That's a kind of gross looking answer, but I don't know what to do about it. Let's go back and see if we did everything right. Okay, in rectangular, we couldn't integrate it because of the y squared inside the square root. So we had to change it to polar. So it's z on the top minus z on the bottom, which gave us 2 square roots of a squared minus r squared. Okay, and then r went from 0 out to that edge of that circle, which we found over here to be a cosine theta. All right, and then I know that you only have to go 0 to pi to get all the way around, because this much of the cosine curve will give you the circle. Okay, then I integrated, which I'm a little shaky about, but I did get an answer. U is a squared minus r squared, du is minus, so I confusedly put another -2 in there and a -1/2, which took care of itself later. And then I integrated 2/3, and then I switched back, a squared minus r squared. I think it's good. If I made a mistake, fix it. Okay, but the logic of everything I'm doing is right, but it is getting kind of late. Okay.